Hello, this is Lubaba Tasnia and I will be discussing about the basic physical part of robot and how I designed the robot. At first, for my robot's body, here inside the robot's children part, we can see the robot body shape. I choose a rectangular shape for my robot's body. And for my robots to move, here I use 4 rotational wheel. So these are my 4 hinge joints. Here I can see my hinge joints. So one thing we must be careful about, the inside the joint parameter of hinge joint, here we can see the anchor, and the anchor value must be same of the translation value inside the endpoint solid. And here I set my rotational motor cylindrical shape. I did the same for 4 of my hinge joints. And for my robot, I use 2 distance sensor and 1 camera and 1 GPS sensor. For my distance sensor, left and distance sensor right, I need to set the translation and rotation value, and also need to choose the shape of my distance sensor. If I zoom a little bit, I can see the shape of my distance sensor is rectangular. And here we can see the rays of distance sensor. By clicking view and optional rendering, show distance rays, we can see the distance rays. And for my camera, I use sphere shape. Here I can see my DEF camera. Inside the children part, I use the shape of sphere shape. So one thing we must be careful about, that the distance sensor, we should rotate the distance sensor in such a way that the x-axis stay in front. So here we can see my x-axis stays in front. For DS right is the same. So this is all from me. Thank you.
Assalamu alaikum, I am Tiana and my ID is 18101229. So this is the code for our project. We use C++ because the Windows version of Webot has a built-in compiler for C++. So at first we implemented some libraries and defined time step as 64. That means the robot will give us update after each 64 milliseconds. We took a distance sensor pointer and sent the distance sensors as DS right and DS left, which we renamed here, and we took a camera pointer and enabled the time step, and we took a motor pointer and set the wheels as wheel 1, wheel 2, wheel 3 and wheel 4, which we renamed inside the hinge joint. We set the wheels position to infinity so that the robot can move up to infinity. Initially the upper obstacle counter is 0. When it is 0, the code will not enter the if block, it will enter else block, and when it is 0, the left speed and right speed is 1, that means the robot will move straight. When the robot detects an obstacle, it will send a value that is less than 950, and then the obstacle counter will be set to 100. So now the code will enter if block, and the obstacle counter will be decremented, and the left speed will be 1 and right speed will be -1. That means the robot will move to right. So when the robot detects an obstacle, it will move to right. And from here we will select the controller code file, and then we will compile from here, and we previously compiled the code, and let's run. So we can see the robot is detecting object and moving right. So the code is working.
Hello, my name is Hijam Irfan Tahsin Alif. My ID is 18101515. Here we can see the Webot has been completed and the code has been compiled. The robot we have created is a object recognition robot, and it will stop and move away from the object it's being shown. If we simulate the object, we can see the robot will start to go, and when it will see an object in the camera, it will move away from the object and go on a new path. Here we can see the camera code which is being used. In the camera code, we can see the camera is using a timestamp and using the object recognizable is enabled in the timestamp. So in every 64 milliseconds, the object the robot is getting new feed and going to and starting a new path. Thank you.